Everyone, so with the Speechaya project, our goal was to create a multilingual LLM that can hear and speak. So next slide, please. And we may wonder why we need to adapt LLM to speech modality. There are many reasons, but one important reason is that more than 90% of human languages are primarily oral, meaning that is these languages are not written actually. And these languages are often called low resource languages, but the fact is that these languages are only resource in text. So they are not really low resource in speech, for example. And this is why many important, many languages are underrepresented in technology, which is mainly focused in text. As the majority of human languages are not written, this suggests that if we really want to democratize the LLMs to everyone, we need to consider speech modality. So how can we achieve this? Next slide, please. How can we achieve this? So we want an LLM that can hear and speak in a unified fashion. One way to achieve this is to represent the speech as a text-like data, so we can train any LLM on that. For that, we used the speech tokenizer approach, which converts the speech modality to discrete tokens. And these discrete tokens can encode the content, the phonemes, the speaker identity, the rhythm, and many other things. And this model is totally unsupervised and is trained end-to-end to quantize the continuous speech. And our speech tokenizer is trained on English common voice only, but in the future, we want to train it on more data and languages. Next slide, please. And since now, thanks to the speech tokenizer, we can represent speech as a text-like data, we can just train any LLM using the next token prediction task. We can combine speech and data in many ways. So we used the speech-only data, so the LLM learned to understand and to generate from raw speech. We also used text-only data to ensure that the LLM retains its previous text knowledge acquired during the pre-training. And we can also interleave the text and speech data to form a bimodal instruction dataset. So to have this data, we used the common voice and Libre speech. And we only work on English and French. So next slide, please. Right now, we are training the small Qwen2 model on French and English only, but in the future, we would like to consider other languages, but for now, only for English and French. And the model is still in training right now, and it continues to improve in ISR, but it needs more training time and more data. Next slide, please. We have many open questions, and I think one interesting question is, can speech-only data improve low-resource language modeling for languages that don't have enough text data? And I think this is a very interesting question to explore. And there are also many open questions about the cross-modal transfer. For example, will the model be able to perform speech-to-speech translation or summarization without being trained on such data? And for the next steps, we project to train the model longer on more data and more languages. And we also want to improve the speech tokenizer to make it really multilingual. As for now, it's only trained on English. Thank you. So next slide. And you have the dataset. You can download the dataset and the models. And thank you very much. That's all from me.